Okay, so we will be talking about system of linear equations. We have a equations. Now, the question is how to solve the equations. For example, suppose we have this equation with 3 variables. So, x 1 plus x 2 plus x 1 x 2 x 3. So, this is 1, x 2 minus x 3 is equal to 1, 2 x 1 plus x 2 plus 4 x 3 is equal to 7. So, suppose we have this system of equation. Now, the question is how we can solve this. So, we want to write this system in a matrix form. How to write it in a matrix form? So, we can just write 1 1 0 1 0 1 minus 1 and 2 1 4 x 1 x 2 x 3. This is equal to 4 1 7. We can write any system of equation is of the matrix form like this. So, because if you take this first row, this is 3 by 1 matrix, this is 3 by 3 matrix, this is 3 by 1 matrix. So, if you multiply these two, it will give us 3 by 1 matrix, that is same. So, what is the first row of that? So, this into this. So, x 1 plus x 2 is equal to 4, that is the first equations. Then the second one, x 1 into 0, x 2 minus x 3 equal to 1, x 2 minus x 3 equal to 1. And the third one, 2 x 1 plus x 2 plus 4 x 3 equal to 7. So, this is any system of equation can be written as matrix form like A x equal to b. So, this is our A matrix, this is our x variable and this is b. Okay. B is the this is called coefficient matrix and this is the variable vector and this is the b. So, now the question is how we can solve this, how we can get the solution of this system, whether the solution exists or not, all this type of question we will discuss here. So, whether this system is, if it is having no solution, then it is called inconsistent system. If there is a solution, then it is called consistent system. So, if there is, so now the question, if there is a solution, if it is infinitely many solution, finitely many solution, unique solution. Now, suppose we have a non-singular matrix, if A is determinant of A is 0, a non-zero, then we have a inverse of this. So, then we have a unique solution, then we can multiply A inverse. Suppose A is a, here is a singular A is a square matrix. So, if A is a square matrix, we can think of determinant of Y. So, if the determinant of A is not equal to 0 and if A is a square matrix, then determinant question will come. Then it is a non-singular matrix, then the inverse exists, then we will multiply x is nothing but that is B. So, if it is a non-singular square matrix. Otherwise, we have to go for different way, because this may not be a always square matrix, it may be 4 by 3 or it may be any order. So, for that we need to take what is called augmented matrix. So, yeah, so what is the augmented matrix? Augmented matrix is, we take this matrix A along with this vector B. So, this is called augmented matrix. Okay. This is called augmented matrix. So, now the question is how we can use this augmented matrix to. So, suppose we denote this matrix by A bar. Now, we will just apply the row operation on this augmented matrix and we will reduce to a some simpler form. So, how we will do that? We will see. So, what is the augmented matrix corresponding to this equation? This is nothing but we have 1 0 2 1 1 1 0 minus 1 4 and we have a b component over here 4 1 7. Okay, so, this we can have a space over here to indicate that that is coming from the b. So, now we apply the row operation on this. We reduce this to the row equivalence echelon form. So, this is how we do that. So, we just replace this R 3. So, if you multiply, so we want to make it 0. So, we will do the R 3 is going to R 3 minus 2 R 1. If you do that, so this first row will be remain same, second row will be remain same, and the third row this will become 0, and this will become this is minus 1, and this will become 4 again, and this is 2. So, 7 minus 2, this is minus 1 like this. So, again if we do this another row operation. So, now we have to, if we add these two. So, yeah. So, if we just, or if we subtract this. So, R 2 R 1 is going to R 1 minus R 2, and also if we do the R 3 is going to R 3 plus R 2. So, this will give us what? So, we are just R 1 is going to R 1 minus R 2. So, this 1 0, then we have a 1 3, R 2 we are not changing anything, 0 1 minus 1 1, and R 3 we are changing, we are just doing the addition 0 0, then 3 0. Okay. So, this is the one we are doing. So, now this is the R 1 is going to this. Now, if we divide this by again if we divide again, R 3 is going to say R 3 is going to half of R 3, then this will become how much? 1 0 1 3, 0 1 minus 1 1, then 0 0 1 0. Okay. So, now if we just add these two up, then this will become 0. That means, R 2 is going to R 2 plus R 3. R 2 is going to R 2 plus R 3. So, then this became, so R 2 plus R 3. So, this will, so first one is remain unchanged 1 0 3, then this will change, this will be R 2 plus R 3 is not a good idea, because no, not R 2 plus R 3, we want to make this to be 0. So, we can add this. So, R 2 is going to R 2 plus R 3. Yeah. So, now this will be 0 1 0 1 0 0 0 0. Okay. So, this is coming from A part. So, rank of A is nothing but rank of A is 3, and what is the rank of the augmented matrix? Again rank of the augmented matrix is also 3, that is important. Rank of A bar is also 3. Okay. Now, if the rank is 3, then that means it is a non-singular matrix. So, that means inverse will exist, then we can directly go for the inverse way to get the solution. So, A inverse B, but beforehand we do not know the rank. So, we have to get the rank, we have to do like this. Now, from here how we can get the solution? So, this has a unique solution. So, from here we can just say x 1 equal to 3, x 2 is equal to 1, and x 3 is equal to 0. Okay. I think this will become 0 somehow. You please check the calculation, and this will become 0. Okay. So, now this is the unique solution. Now, here there is an observation that rank of the matrix and rank of the augmented matrix should be same in order to have the solution, otherwise there will be no solutions. So, we will write that if the rank of the matrix and rank of the augmented matrix are not same, then there will be no solution, because we will end up with a, if we have augmented matrix A. So, why is so? Because if we have a augmented matrix A and if we have a coefficient matrix A and if we have a B. So, this is our augmented matrix. Now, if the rank of the augmented, if the rank of A is less than the rank of the augmented matrix, then eventually what it will end up? Say suppose rank of for example, rank of A is say 3 for some example, and suppose rank of augmented matrix is some 4. So, that means what? That means if we apply row reduced form of this, so it will eventually gives us like this. So, last row will be became 0, but we still have a coefficient over here. So, some alpha 1 over here, and we have. So, that means it cannot have a solution for that, because to have the solution there is no exercise which will give you the alpha, because all are coming 0. So, that means the rank of, anyway, there is a proof for this. I am not discussing the proof now. We may be giving the proof in the note. So, rank of A has to be same as rank of the augmented matrix. If it is not same, then there is no solution, because if we take this augmented matrix, if we keep on applying the row operations, elementary row operation on this, then if the rank is not same, then eventually we will end up with a zeros in the last row with some non-zero value in the B part. So, like this. So, this will be end up with some zeros over here if the rank is not same, and here this is non-zero, some alpha. So, that is telling us that is not possible. So, that means there is no xi which will give us this, because all are coming to be 0. So, that is the problem with this. So, this has to be there for having solutions, and then it is called a consistent solution. So, if the rank is, so just recap this. So, the rank, if the rank of A is not same as rank of the augmented matrix, then we call this is a inconsistent system. Inconsistent system. Inconsistent means no solution. Solution does not exist, or solution does not exist. This means no solution, inconsistent, no solution. So, to have a solution, we need to have this condition, the rank of a matrix should be same as rank of the augmented matrix. Then we have a solution. Now, the question is whether solution is unique or not, those we will discuss. So, if the rank of this, then we say the system is consistent. If the rank of A bar is same as rank of A, then the system has a solution. Then it is called consistent system. Consistent system of linear equations. This means it has a solution. It has a it may be infinite number of solutions, finite. So, but it has a solution. Has solutions or solution. Okay. So, now the when it will have unique solution, if you have a system A x equal to b, when it has unique solution, if A is non-singular, that means then we have a unique solution and that is nothing but A inverse B. Okay. Now, if it is not, then we have a, if there is a then we have a infinitely many solutions. If there is if it is not unique, if the rank of, so that means if the rank of augmented matrix, which is same as rank of A, is less than the number of variables, then we have a infinitely many solutions. It is consistent and we have a infinitely many solutions. Okay. So, these are the possibilities. So, we will take some example to find the solutions of a system of equations. Okay. So, let us take an example. So, in general, if we have to write in general, so in general any system of equation is of this form: a 1 to x 2, a 1 n x n equal to b 1, a 2 1 x 1 plus a 2 2 x 2 plus a 2 n b a x x n, yeah, a x n equal to b 2. So, dot 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 a I 1 x 1, this is the ith row, a I 2 x 2. We can have jth column a 1 j x j if you like. Anyway, a I n x n equal to b I dot 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 a m 1 x 1. Suppose there are m equations in the system, a m 2 x 2, a m n x n equal to b n. So, there are, this is called system of equations. So, this can be written as of the matrix form a 1 1, a 1 2, a 1 n, a 2 1, a 2 2, a 2 n, a m 1, a m 2, a m n, x 1, x 2, x m, x n. Actually, there are m variables, b 1, b 2. So, this is m cross n and this is n cross 1. So, this will be b m, this is m cross 1. This is a, now this is our A matrix, this is x, this is b. So, A x equal to b of this form. So, now the augmented matrix is A b. Now, we already talked about rank of, this should be same for the having the solution in the consistent system of equations. So, now we will take some examples. This is the general form of any system of linear equations. Okay, just a quick example: x 1 plus 2 x 2 minus x 3 x 10 minus x 1 plus x 2 plus 2 x 3 equal to 2, 2 x 1 plus x 2 minus 3 x 3 equal to 2. So, this we can write as matrix form 1 2 minus 1 minus 1 1 2 2 1 minus 3 x 1 x 2 x 3. This is B is 10 to 2 like this. Okay. So, now this is our A matrix, this is our x variable vector and this is our B, this is the coefficient matrix. Now, we have to find the rank of A and rank of augmented matrix. We have to first check whether this system is consistent or not. So, for that rank of A and rank of augmented matrix would be same. So, let us take the augmented matrix and we will do the row operation on this. Minus this is A 2 1 minus 3 and along with the B vector. So, this is the augmented matrix. So, we will do the row operation. So, if we do the row operations, so we first multiply this with 2 and subtract with this row and then we can add this and this. So, like this if you do the row operation eventually we will be getting this row reduce row equivalence matrix of this 1 2 minus 1 10 0 1 1 by 3 4. We have to work out. I am just skipping this part 0 minus 3 1 minus 1 minus 18. So, by doing just the row operation on this matrix we will get this matrix. Okay. So, now yeah, from here what we can say, what is the rank of A? Yeah, again we can do another row operations on this by adding these two. So, eventually we will be getting this is the intermediate one. So, but again if we do the row operation eventually we will be getting this matrix 1 0 minus 5 by 3 2. We have to just subtract by 5 and then add with the another row 0 1 1 by 3 4 and 0 0 0 yeah. So, 0 0 0 and minus 6 yeah minus 6. Anyway, you can just work out with this. Here we have a problem. What is the problem? So, this is equivalence to this matrix under row operations. So, this is our we have problem. Now, what is the rank of A? Because this we get just by applying the row operation on this, because row operation we will not, for row operation we will not mixing this part with this. If we have to do the column operation then is so. So, rank of A is 2, but what is the rank of the augmented matrix? Rank of augmented matrix is 3. It is not true, because if we take this one then the determinant is non-zero. There is a problem. So, this rank is not same. So, rank of A is not same as rank of A bar. So, this is inconsistent. Why? Because see, for this if you consider this row there is no such x 1s which will give us 0 into x 1 plus 0 into x 2 plus 0 into x 3 is equal to minus 6. So, this is has no solution basically. So, we are reducing this to another system of equations. While doing row operation, that means we are say we have a system of equation x 1 plus 2 x 2 equal to 4. X 1 minus x 2 is equal to say 6. Now, row operation means we are just say it is a 6. So, we are just multiplying this with subtracting this with 2. So, this will be reduced to 3 x 1 plus x 2 is equal to 2 x 1 minus x 2. So, this is a row operation on the augmented matrix. So, row operation, while we are doing the row operation on the augmented matrix, we are achieving the equivalent system of equations which are same solutions, because we are just multiplying some, we are exchanging some row, we are multiplying, or we are just adding some row and subtracting with that. So, all the row operation we are doing on augmented matrix is giving us basically the same system of equivalent system of equations which are having supposed to have the same solutions. So, now this system has equivalence with the original system, but this system has no solution because these are all zeros coefficient matrix and here we have non-zero. So, this system has no solutions. So, that is why this rank is not becoming same. So, this is another way to look at the why the rank of augmented matrix and rank of the matrix A should be same for the consistent system. So, if the rank is not same, that means this is the equivalent system we will end up with like this, which has no solution because all are 0, there will be no exercise which will satisfy this will minus 6. Okay. So, again I am telling you the while we will doing the row operation on the augmented matrix, we are just reaching to the equivalent system of equations which have same solution with the original system. So, now this system has no solutions, that is why it is, and again from this. So, that is why the rank of the augmented matrix should be rank of the matrix. So, that means this system is inconsistent. So, inconsistent system of equations. Okay, because it has because rank of augmented matrix and the rank of this is because the equivalent system is what? Equivalent system is x 1 minus 5 by 3 x 2, x 3 is equal to 2, then x 2 plus 1 by 3, x 3 is equal to 4, and then 0 is equal to minus 6. So, this is the equivalent system corresponding to the original system, because this system we got by applying row operation on the augmented matrix. But this system is inconsistent because this has no solutions, it is not possible. So, that means, and also it is reflecting from the rank. So, that means for consistency we should have rank of a matrix is same as rank of the augmented matrix. So, we can we can work out on another example. This I am giving you as exercise. So, if you take this system x plus 2 y plus z is equal to 1, 3 x plus y plus 2 z equal to 3, x plus 7 y plus 2 z equal to 1. So, we can take the augmented matrix. So, this is the coefficient matrix 3 1 2 1 7 2, and if we take the B. Now, if we apply the row operation, we will get the equivalent system which is having same rank. So, eventually we will end up with the row reduced echelon form 3 by 5 1, 0 1, 1 by 5 0, then 0 0 0 0. So, that means rank of the matrix A and rank of the augmented matrix is same, which is 2, which is less than the number of variables. So, it has infinitely many solutions. So, we can just equivalent system is nothing but x 1 plus 3 by 5 x 3 is equal to 1 and x 2 plus 1 by 5 x 3 is equal to 0. This is the equivalent system corresponding to this system. So, these are same solutions. So, we can just take this infinitely many solution, x 2 is equal to minus 1 by 5 x 3 and x 1 equal to 1 minus 3 by 5 x 3. We can choose any x 3, any real number. So, this has infinitely many solutions. Thank you. Thank you.